Hi. So today we're going to, I hope you can see that, lab preparation of oxygen gas. Apparatus, I've drawn it on the board. In blue are the chemicals. So hydrogen peroxide solution. Remember, if you remember the elephant's toothpaste, it's that same chemical, except this is diluted. So hydrogen peroxide solution, we'll pour that through the funnel into there. So the liquid solution is hydrogen peroxide solution. Then we're going to add a black solid. Black solid, manganese 4 oxide solid, and that is a catalyst. It's going to speed up the reaction, but is itself not going to be changed. The formula is MnO2. So, I hope you can see that. That's the apparatus drawn. When pupils draw it, they draw around here. They block the flow. And there's a long tube going all the way down. And then there's a short tube. So when bubbles of oxygen happen from the surface, bubbles of oxygen come off here, they can't go up the long tube because it's underwater, and they go up the short tube and we collect them. They're collected in a trough of water. Now let me show you the real apparatus. The real apparatus, I'll go through that now. Just move this away. It's this here. I hope you can see that. Let's pull it back a bit so you can see. Flat bottom flask, thistle funnel, delivery tube, trough. Any gas will come out of here. I've got some test tubes of water that are full of water in the trough of water to make it easy for me to collect. I've got a couple of bungs which I'm going to just collect some tubes of oxygen gas. And get Bunsen burner lit so that I can do the testing of the gas as we want to. Some splints. Right, I'm almost ready to start. So, chemicals. Hydrogen peroxide, we're going to pour down that thistle funnel. We need to start with, this is the catalyst, manganese 4 oxide, MnO2. So dismantle the apparatus, get a spatula, get some of catalyst, this is black powder. Put the apparatus back. When I'm ready, I am now, I get the solution of hydrogen peroxide and I pour that through there. I keep pouring until the bottom of that long tube must be under the solution. Which I'm pretty sure it is now. Initially, the first kind of 20 seconds of bubbling will be the air that was in there. So the air comes over first, then if you get test tubes, fill them with water and turn them upside down and put the test tube over the delivery tube there. That's one test tube. With the bung, you can bung it. Underwater, bung it. That is one test tube of oxygen gas. Another test tube. Bung it. Sorry. I suppose I'm trying to rush it, and things never work out when you rush things. You've got to do them nice and gently. Now these are the ones, I'm just going to leave them. I'm going to leave them if I can, and I can't. So anyway, what do we need to know? Having made oxygen gas, this is oxygen gas, bubbles of oxygen gas. Having made oxygen gas, then you can test it. You can test the properties of oxygen gas. And I have a memory aid, cod slipton, and cod slipton takes me through the properties which I want to go through with you. So, colour. Colour, oxygen is colourless. O for odour, oxygen is odourless. So O for odour, doesn't smell, odourless. D, density. The density of oxygen, you see there's still bubbles coming out. I'm going to fill this tube again. The density of oxygen is a teeny weeny bit more dense than air. 24 litres of oxygen weigh 32 grams. And 24 litres of air weigh about 28 grams. Or 29 grams. Air's a mixture. So if air, 24 litres weighs about 29 grams, 24 litres of oxygen weighs 32 grams, then the oxygen is slightly more dense than air. Colour, odour, density. Solubility. Now solubility dissolves in water. It has to dissolve in water for aquatic life to exist. So it dissolves in water, and there is always, in normal rivers, there's dissolved air and dissolved oxygen in the water. And that's what enables aquatic life to live. So solubility, L for litmus. Now, litmus. I've got some universal indicator, and I'm going to shake this with the universal indicator, and it stays green. The indicator stays green, telling you that oxygen is a neutral gas. So, neutral gas. I for inflammability. Now this is the one where boys get mixed up. Sorry, I teach in a boys' school, which is why I keep saying boys. But this is where pupils get all mixed up. Now, if I want to see whether this burns, I can light it. And when I'm lighting it, I should be looking at the gas. I'm not looking at the flame here. There, it's not lighting. If I put it in, see, it burns better. My splint burns better when it's in, because things burn very well in oxygen. Burning is a reaction with oxygen. So in there, things burn really well. But, crucially, you need to know that the gas itself does not burn. Right, the test. Test for oxygen is, it will relight a glowing splint. Glowing splint. There, relight. Relighting of a glowing splint is the test for oxygen. Uses for oxygen, I think you should say that oxygen is used to get iron from iron ore. And N for notes, anything else? Well, the main thing about oxygen boys and pupils confuse is the idea that it doesn't burn. Oxygen is not flammable, it does not burn. However, things burn very well in it. All burning is a reaction with oxygen, as you should have learnt in some of my previous videos. Okay, so let me get a pen. I hope you can see that reaction. The reaction that happens, this is hydrogen peroxide. Hydrogen peroxide decomposes. It decomposes, it breaks down to give you water and oxygen gas. And the oxygen gas with the bubbles that you saw and that I collected. This manganese at 4 oxide, 4 is the valency of manganese. Manganese 4 oxide, the formula MnO2, solid, black solid, that is a catalyst. Now catalysts speed up reactions but are themselves unchanged at the end of the reaction. So none of it gets used up. It's all there. I could recover it all if I wanted. I'm not going to, I'm going to chuck it away, but I could recover it if I wanted. And this kind of reaction is called catalytic decomposition. Do you remember thermal decomposition using heat? Well, this uses a catalyst. It's not thermal, it's catalytic decomposition. What else do you need to know? Well, there, cod-slipton, colourless, odourless, density is a little more than air density. Soluble in water. L for litmus indicator is a neutral gas. Neutral gas. I for inflammability, it does not burn. P for poisonous, not poisonous. T for test, test, relights, a glowing splint. Uses to get iron from iron ore. Notes, things burn very, very well in oxygen. Right, so cod-slipton, those properties, those are the ideas of oxygen you need to know. So you need to know what reaction produces it, a catalytic decomposition makes it, and you need to know the properties of it, and you need to know how to make it like that. You need to know the chemicals, and you need to know the apparatus. What's that apparatus? Okay, we'll stop there.